Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on area and dealing with the area of regular hexagons. And if you need any extra help in finding the area of regular hexagons, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 41A, there's a dedicated video tutorial there on finding the area of regular hexagons. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says ABCDEF is a regular hexagon with side length 6 centimeters. So let's have a look here. ABCDEF and a side length of 6 centimeters. And the hexagon, as you can see, has been split up into 6 identical equilateral triangles. And because they're equilateral, we know that each of the angles is 60 degrees. And if this side length is 6 centimeters, it means that this length is 6 centimeters, that length is 6 centimeters, and so on. And part A says P is the midpoint of the side AF. So if we've got this side AF, P is the midpoint, and we've been asked to calculate the length of OP. So OP is the distance from the center of the regular hexagon to the point P, which is the midpoint of the side AF. So we want to find this length here, this dashed line. Now, if we want to find the length of this line, OP, what we're going to do is we're going to look at this equilateral triangle, and we're going to consider the fact that we've cut it vertically in half. So this is a right angle, and then we had that this side length was 6 centimeters from A to F, but from A to P would be half of that, so that's going to be 3 centimeters. So from A to P is 3 centimeters, and from O to A, well, remember it's an equilateral triangle, so if the whole side length for AF was 6 centimeters, O to A would be 6 centimeters. So we've now got this right angle triangle, this triangle OPA or OAP, and we want to find this distance here. I'm just going to call it H, the height of the triangle. So we want to find H. So to find H, we're going to use Pythagoras' theorem. So remember, Pythagoras' theorem is A squared plus B squared equals C squared, where A and B are the two shorter sides and C is the hypotenuse, the longest side of a right angle triangle. So if we look at this triangle OAP, it's a right angle triangle. We've got our two shorter sides where they're going to be the 3 centimeters and the H, and the largest side, the C, the hypotenuse, is the side opposite the right angle, so that's the 6 centimeters. So A, let's call A this side, let's call B this side, and let's call the side C. So labeling the sides A, B, and C, where A and B are the two shorter sides, and C is the hypotenuse. So A squared, that's going to be 3 squared, plus B squared, that's going to be H squared, equals C squared, and C was 6 centimeters, so that's 6 squared. Now let's work this out. 3 squared, well, 3 times 3 is 9, plus H squared is H squared, and that equals 6 squared, and 6 times 6 is 36. So we've got that 9 plus H squared equals 36. Now we want to solve this, so let's get rid of this 9, so let's take away 9 from both sides of this equation. So on the left hand side, we're going to be left with H squared, and on the right hand side, we had 36, we're taking away 9, so that's going to be 27. So H squared, this side squared, is 27. So now to find H, we're going to square root, so H is equal to the square root of 27. So let's work this out. So let's work out the square root of 27. And if we do the square root of 27, that's equal to, so H is equal to, I've got that's equal to 3 root 3 centimeters. So from O to P, the length of that line would be 3 root 3 centimeters. Or as a decimal number, if you wrote it as a decimal number, that would be H is equal to 5.1961524 and so on centimeters. So here we could write 3 root 3 centimeters. So 3 root 3 would be a perfect answer. Or you could write this answer, you could write it out in full, 5.196 and so on, or you could round it, so perhaps you could round it to perhaps 5.196 to 3 decimal places, and that's it. So we've worked out the length of OP, and we used Pythagoras' theorem to do it. Okay, let's look at part B. So part B says calculate the area of triangle AOF. So let's find triangle AOF. So AOF. So AOF, so it's one of the equilateral triangles. We want to find the area of this triangle, AOF. So to find the area of a triangle, remember it's half the base times the height. So here, in terms of this triangle OAF, the base would be, well, that's the whole way from A to F, so that's going to be, we've got 3 centimeters and another 3 centimeters, so the whole base from A to F would be equal to 6 centimeters, and we know that because we're told the side length of the hexagon was 6 centimeters. So we've got the base of the triangle. The height of the triangle, we've just worked it out. We've worked it out as 3 root 3 or 5.196 to 3 decimal places. So we've got the height of the triangle. I'm going to write 3 root 3 because that's exact, it's not rounded, so it's 3 root 3 centimeters. So we've got this triangle AOF, and if we want to find its area, we're going to do half the base times the height, and that'll give us the area. So let's do that. So the area is equal to half the base times the height. So it's going to be half the base, which was 6 centimeters, times the height, which was 3 root 3 centimeters. You could use this 5.196152 and so on. And if you've got it on your calculator display, that's fantastic. One thing I would say is be careful about using a rounded version of that answer. Here we rounded to 5.196 to 3 decimal places. I probably would want to use a slightly more accurate version. Some students may have rounded this answer to 5.2 centimeters, and then if they're using 5.2, the area of the triangle is not going to be very accurate, or not as accurate as it should be. So I would perhaps use either the full answer here if it's on my calculator display, or use more decimal places, 5.19615. Perhaps something like that, or ideally use the exact answer, 3 root 3. So that's what I'm going to do. So half of 6 times 3 root 3. So typing that into my calculator, a half multiplied by 6 multiplied by 3 root 3 is equal to 9 root 3. So the area of the triangle is 9 root 3 centimeters squared. Or we could write it out as a decimal number as 15.588 and so on centimeters squared. And you could perhaps round that if you wanted to, but I probably would give my answer as 9 root 3 centimeters squared. Okay, and let's look at our last part. The last part, part C, says calculate the area of hexagon ABCDEF. So we want to find now the area of this whole hexagon. Now we've found the area of one of these triangles. The area of triangle AOF was 9 root 3. So that means that the area of this triangle at the top here, this one, is 9 root 3 centimeters squared. The area of this triangle, because remember they're identical, 9 root 3 centimeters squared, 9 root 3 centimeters squared, or if you had it as a decimal number, you could write 15.588, 15.588, 15.588, and so on. Obviously use as many decimal places as you can because that makes your answer more accurate. 9 root 3 centimeters squared, 9 root 3 centimeters squared, and in this triangle here, 9 root 3 centimeters squared, and that's the whole triangle. Be careful whenever we split that triangle up into our two right angle triangles. Make sure in part B that you worked out the area of the whole triangle AOF and not just the right angle triangle. So if you worked out the area of the right angle triangle, then remember to double it to get the whole area of triangle AOF. So we've now got 6 identical triangles, each with an area of 9 root 3 centimeters squared. So now let's just work that out. So the area of the whole hexagon will be 6 multiplied by 9 root 3. And that would give us an answer of 54 root 3 centimeters squared. So that's the area of the hexagon. Or as a decimal number, if you've got this on your calculator display, you could just do multiply by 6, and that would be 93.53 centimeters squared to 2 decimal places, and that's it. So the answer is 54 root 3, or 93.53 centimeters squared to 2 decimal places, and that's it. Okay, let's have a look at our next question, question number 2. So question number 2 says ABCDEF is a regular hexagon with centre O, so that's the centre of the regular hexagon. The side length of this regular hexagon is 8 centimetres. Remember, it's regular, so all the sides have got the same length. And then part A says M is the midpoint of the side EF, so M is the midpoint of this line. And we've been asked to calculate the length of OM. And then part B says to calculate the area of the triangle, and part C, find the area of the hexagon. So let's do that. So we want to find the length in part A of OM, so the length of that line. So remember here we've got our triangle, that's an equilateral triangle because we can cut a regular hexagon up into 6 equilateral triangles. So this is an equilateral triangle, and if we cut it in half, that'll be a right angle, like so. And we know that the whole side length is 8 centimeters, so that means that this distance would be 4 centimeters from M to F, or from E to M. And the distance from O to F, remember they're equilateral triangles, so if we had another triangle, say here perhaps, if that's 8 centimeters, that length's 8 centimeters, and that length's 8 centimeters. So each of these sides are 8 centimeters of this equilateral triangle. So when we cut it in half, this part will be 4 centimeters, and that side, the hypotenuse of the right angle triangle, will be 8 centimeters. Now we're going to do Pythagoras' theorem. So let's deal with the sides. So A and B are the 2 shorter sides, and C is the longest side opposite the right angle. So Pythagoras' theorem, A squared plus B squared equals C squared. So A squared, that's going to be 4 squared, plus B squared. Well, we don't know what B is. We could call it H, we could call it X, we could even just leave it as B. So H squared, I'm going to call it H for the height of the triangle, is equal to C squared, which is 8 squared. 4 squared is 16, plus H squared equals, and 8 squared is 64. And then H squared, if we take away 16 from both sides of that equation, we get that that's equal to 48. So this side squared is equal to 48. We want to find out what h is, so we now need to square root this. So h, the height of the triangle, is equal to the square root of 48. And then if we work out the square root of 48 in our calculator, 4 root 3, so 4 root 3 centimeters, so O to M could be 4 root 3 centimeters, or as a decimal number it would be equal to, H would be equal to 6.92820323 and so on. And I tend not to want to round that because I may need to use it later. Okay, so part A is calculate the length of OM. Well, it could be 6.9282 and so on centimeters, or you could write it as 4 root 3 centimeters. That's the distance from O to M using Pythagoras' theorem. Okay, part B. Part B says calculate the area of triangle OEF. So this is a bit familiar, thinking back to question 1. So OEF, that equilateral triangle, we want to find the area of one of them because we know there's 6 of them, and then we can find the area of the hexagon. So triangle OEF, that's a whole triangle. So we want to find the area of the whole triangle. Be careful not to just consider one of the right angle triangles, we're considering the whole triangle. So remember, it's half the base times the height. Let's write that down. The area will be equal to half the base times the height. So that's half of the base of the triangle. So this whole equilateral triangle, the base would be, well, that's another 4 centimeters. So the whole base is 8 centimeters, which we were told in the question from there to there. So it's half the base times the height. So it's half of 8 multiplied by 6.9282 and so on, or 4 root 3. So that would be multiplied by 8 multiplied by 6.9282 and so on. And if it's on your calculator display, fantastic. Or you could remember, right, 4 root 3. And if we do that, we've got half multiplied by 8 multiplied by answer, because it's still on my calculator display, and that gives me an answer of 16 root 3. So the area of the triangle is 16 root 3 centimeters squared, or as a decimal number, 27.7128 and so on centimeters squared. Okay, and then part C. Part C says calculate the area of hexagon ABCDEF. So we've now got the area of one of the triangles as 16 root 3. So the area of this triangle is 27.7128 and so on centimeters squared, or 16 root 3. Now remember, there's 6 equilateral triangles and they've all got the same area. So we just need to times the area of one of the triangles, this equilateral triangle that we found the area of in part B. We just need to multiply that by 6. So let's take our answer to part B, the area for the triangle, which is 16 root 3, and multiply that by 6. Or remember, we could do 27.7128 and so on. Don't round it, multiply by 6. So we just need to multiply by 6. And whenever you multiply the area by 6, that's equal to 96 root 3. And as a decimal number, that would be 166.2768775 centimeters squared. And so that you could write either one of these as your answer, either 96 root 3 centimeters squared or 166.2768 and so on, or you could round it, centimeters squared. And that's the area of the whole hexagon. And that's it. Okay, let's have a look at our next question, question number 3. So question number 3, we've got this regular hexagon and we're told the side length is 4 centimeters and we've been asked to work out the area of the hexagon. So this time we don't have the part A and part B and part C to help us, so we're going to have to remember those steps. So if I wanted to find the area of this regular hexagon, I would cut it up into triangles, so equilateral triangles. So I've chopped it up into 6 equilateral triangles, identical equilateral triangles. The side length of it is 4 centimeters here, so that means obviously this distance is 4 centimeters as well. And we're going to chop the equilateral triangle into a right angle triangle so we can find its area nice and easily. So in terms of this right angle triangle here, the distance from here to here would be 2 centimeters halfway across. So that's 2 centimeters and that's 4 centimeters. And let's call the height of that triangle h. So we're now going to use Pythagoras' theorem to find h, the height of the triangle. So Pythagoras' theorem, let's label the sides. The two shorter sides are a and b, and the longest side is c. So we've got a squared plus b squared equals c squared. A squared, that's going to be 2 squared, plus b squared, that's going to be h squared, is equal to c squared, that's 4 squared. 2 squared, that's 4, plus h squared, that's h squared, is equal to 4 squared, and 4 times 4 is 16. Now we're going to take away 4 from both sides, so taking away 4 from both sides leaves us with h squared is equal to 12, and now we need to square root that. So h would be equal to the square root of 12, which is equal to 2 root 3 centimeters. So the distance from here to here, the height of that triangle is 2 root 3 centimeters. So 2 root 3, or as a decimal number, it would be equal to 3.4641011615 centimeters, as long as you don't round that to perhaps 3.5, that would be, you would lose too much accuracy there. So we've found the height of that triangle. Now we need to find the area of the whole equilateral triangle. So we're going to do half the base times the height. So let's write that down. The area of the equilateral triangle is equal to half the base times the height. So half the base of the whole triangle is 4, so it's going to be half of 4 multiplied by the height of the triangle, and the height of the triangle is 3.4641011615, or 2 root 3 is probably easier to write there, 2 root 3. Also, it's on my calculator display, so I can just type in a half multiplied by 4 multiplied by answer, and whenever I do that I get the area of the triangle is equal to 4 root 3 centimeters squared. So that's the area of the triangle. The area of that triangle is 4 root 3 centimeters squared, or as a decimal number 6.92820.323 centimeters squared. So that's the area of one of the triangles. I'm actually just going to go back up there and I'm going to write it in there. So I'm actually going to use the exact value, this exact value of 4 root 3. So the area for this triangle is 4 root 3. The area for this one is 4 root 3. The area for this one is 4 root 3 centimeters squared. The area of this whole triangle is 4 root 3 centimeters squared, 4 root 3 and 4 root 3. So if we take the area of one of them, the 4 root 3, and multiply by 6, that's the area of the whole hexagon. So if we take our 4 root 3 and multiply that by 6, that's equal to 24 root 3. Or you could do 6.928 and so on and multiply that by 6. And whenever we multiply 6, that's equal to 24 root 3, or 41.56921.938 centimeters squared. And we could round our answer, perhaps round it to 41.57 centimeters squared at the end, or just leave it as 24 root 3 centimeters squared, because the question doesn't say we have to give it to so many decimal places. And that's it. Okay, let's have a look at our next question, question number 4. So question number 4 is actually similar to question 3, apart from this time we don't have a sketch. So we're going to have to sketch a regular hexagon, and it's got a side length of 10 centimeters. So let's sketch that. So we've got our regular hexagon, and the side length of the regular hexagon is 10 centimeters, and we want to find the area of the regular hexagon. So let's split it up into our equilateral triangles. And we're going to start by finding the area of this equilateral triangle here at the bottom. So we've got this equilateral triangle, the side length of it is 10 centimeters. So if we cut it in half into a right angle triangle, like so, we've now got that this distance is 5 centimeters, so 5 centimeters from here to here. And the length of this diagonal here is equal to 10 centimeters, because remember that's an equilateral triangle. So we've got this right angle triangle, and we've got the lengths of 2 of the sides, and we want to find the height of the triangle, this h. So we're going to do a squared plus b squared equals c squared. A and b are the 2 shorter sides, so it's going to be 5 squared plus h squared. So 5 squared plus h squared is equal to 10 squared. 5 squared is 25 plus h squared is equal to 10 squared is 100. Taking away 25 from both sides gives us that h squared is equal to 75, and then square rooting h is equal to the square root of 75, which would be equal to 5 root 3. So that means the height of this triangle here is 5 root 3 centimeters, or as a decimal number 8.66025 and so on centimeters. Okay, so we now found the height of the right angle triangle, which is the same as the height of the equilateral triangle. So we can now find the area of the equilateral triangle. So the area is equal to half the base times the height. The base of the equilateral triangle, the whole triangle, is 10 centimeters. So that's going to be a half of 10 multiplied by the height of the triangle, which is 8.66025 and so on, or 5 root 3, so 5 root 3 close brackets. So if we work out half times 10 times 5 root 3, that'll give us the area of the equilateral triangle. So let's do that. And that would be equal to 25 root 3 centimeters squared. So that's the area for this triangle, 25 root 3. Or as a decimal number, if you worked it out as a decimal number, it would be 43.30127.019 centimeters squared. So now we know the area of one of the triangles. We now just need to multiply by 6 to get the area of the whole regular hexagon. So let's do that. So the area of one of the triangles was 25 root 3, or 43.3 and so on. We're then just going to do multiply by 6, and that'll give us our answer. So if I just do times 6 on my calculator, that's equal to 150 root 3, or as a decimal number 259.8076211 and so on centimeters squared. And that's it. That's the area of the regular hexagon, 150 root 3, or 259.8076 and so on centimeters squared. And you could round that perhaps to 259.81 centimeters squared to 2 decimal places, to 2 dp. Okay, let's have a look at one last question. Okay, so question number 5. So question number 5 says this time, a regular hexagon has got a perimeter of 72 centimeters, and we've been asked to calculate the area of the hexagon. Okay, so for this question, I'm going to do a sketch. Okay, so there's our regular hexagon. And remember, the word regular means that all the angles are the same size, but also each of the sides are the same length. So each of these sides are the same length. So the perimeter of this pentagon is 72 centimeters. So if we take the 72 and we divide that by 6, because there's 6 equal lengths that add together to be 72, that's equal to 12 centimeters. So that means the side length for this regular hexagon is 12 centimeters. And now we've found the side length for the regular hexagon. Now we can just follow the steps that we used in all the other questions. So let's do that. Okay, so to begin with, I've cut it up into 6 equilateral triangles. Now what we're going to do is we're going to work at the area of one of them. So let's cut it up into a right angle triangle. And now we've cut it into a right angle triangle. We're going to find the height of it, the height of that triangle, because that's the height of the equilateral triangle. The base has got a length of 12 centimeters. So that means for the right angle triangle from here to here would be 6 centimeters. And that distance is 12 centimeters, because remember, these are equilateral triangles. So if this side is 12, that side is 12, and so on. So we've got this equilateral triangle that we've cut up into a right angle triangle. But in terms of the right angle triangle, from here to here is 6 centimeters, and that length is 12 centimeters, the hypotenuse. So now we're going to use Pythagoras' theorem to work out the height of that triangle. So a squared plus b squared equals c squared. And remember, c is the longest side, that's the side opposite the right angle, so that's going to be 12 centimeters, and a and b are going to be 6 and h. So 6 squared plus h squared is equal to 12 squared. 6 squared is 36 plus h squared is equal to 12 squared is 144. Now we're going to take away 36 from both sides, and that'll give us that h squared is equal to 108. And that's h squared, so we're now going to square root to find that h is equal to the square root of 108, which is equal to 6 root 3 centimeters. So the distance from here to here, the height of that triangle is 6 root 3 centimeters, or as a decimal number, 10.3923 and so on centimeters. So we've now found the height of the equilateral triangle, and we know the base of the equilateral triangle, the whole way across, would be 12 centimeters from here to here, the side length. We can now find the area of that equilateral triangle, this whole equilateral triangle, by doing area is equal to half the base times the height. That's the half of the base of the equilateral triangle, which is 12 centimeters, times the height of it, which is 6 root 3, or you could use 10.39 and so on centimeters. So if we work this out, we'll find the area for the triangle. So it's going to be a half multiplied by 12 multiplied by 6 root 3, or that. And we get that that's equal to 36 root 3 centimeters squared. So each of the triangles has got an area of 36 root 3 centimeters squared, or as a decimal number, 62.3538 and so on centimeters squared. So now we know the area of one of the triangles. We now just need to multiply by 6 to get the area of the regular hexagon. So let's do that. And that would be equal to 216 root 3 centimeters squared. So that's the area of the regular hexagon, or as a decimal number, that's equal to 374.123 centimeters squared to 3 decimal places, to 3 dp. And that's it. And that's it. So these have been the video solutions to the practice questions on finding the area of regular hexagons. I really hope you found these video solutions useful. If you need any extra help on this topic, if you go to the Corbettmaths videos and worksheet section and scroll down to video number 41A, there's a dedicated video tutorial there on this topic. Alternatively, you can scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.